So YouTube, in this video, I'm just kind of following up a couple of videos I made as an introduction to solving systems of equations. So these are just me going through 4 examples of if I asked you guys to solve a system of equations graphically, how you would go about doing it. And I throw in some interesting forms of the equations here. So let's go through a few examples. So the instructions here will be these. It says, for each of the following systems, let's graph the equation. So we're going to start by graphing these, and then tell how many solutions the system has. So keep in mind, the solution's either going to have none, it's either going to have 1, or infinitely many. Okay, and we shouldn't write infinitely many that way. But basically, we're going to tell how many they have. If there is one and only one solution, though, where the graphs intersect one time, I want to estimate the solution and then plug it back in and check to see if it works. Okay, so let's go ahead and start with system number 1 here. We have 2 equations, x equals 5 and x plus y equals 1. So going ahead and sketching this out here, x equals 5. Now that's interesting. That is a vertical line. Okay, I always have my kids say, well, that's a horizontal line, but what they're thinking is, well, because my x-axis runs left to right, this must be a horizontal line. No, actually, x equals 5 is a vertical line that passes through the x value of 5. Okay, so we say, here's our first equation. We'll sketch it in, and we should label this. We'll call this EQ number 1. And we say x plus y equals 1. So if we plugged in, since this is in standard form, we'll graph it using the intercept method. If we plug in 0 for y, we get x is 1. Okay, so we say x is 1, hits our x-axis at 1. If we plug in 0 for x, hits our y-axis at 1. So that would be up 1, draw a dot. We say, okay, so all of the solutions to our second equation are these right here. And so the first thing we want to do is this. The instruction said tell how many solutions this system has. Well, this system, I'm just going to guesstimate here. This solution has one and only one solution, and it's this point right here, x comma y. So now we need to guesstimate what this point is. We do at least know this. The x value of this point must be 5 because our line x equals 5 kind of goes through that. But I'd say this is about 5 comma, and if I had to guess, I don't know, 5. I know I didn't draw this very well, but 5 negative 4. And this is my guess. Now we said estimate the solution. So 5 negative 4, that means we need to go back now and check this since we came up with one solution. So if I plug 5 negative 4, 5 comma negative 4, back into my first equation, we get this. We get blank equals 5. We're plugging in 5 for x, so we get 5 is 5. It totally satisfies the first equation. So now if we plug this back into the second equation, we get this. X plus y is 1, where x we're saying is 5 potentially, and y is negative 4. So we get 5 plus negative 4 is 1. It's 1. So we get 1 equals 1. So we did find the solution to this system. Totally. And just to kind of back this up, I would like to look at all of our graphs in GeoGebra here. X equals 5 was our first equation. We had x plus y equal 1 is our second equation. And we can clearly see that the point over 5 down 4 was the solution to the system. Totally, dudes. Okay, so that one's out of the way. Let's go ahead and take a look at our second system over here. Second system says y equals 1/2 x minus 5 and y equals 1/2 x plus 3. What I wanted to do in this system was actually hook us up with a system in which where y was already by itself. Essentially, what I'm saying is you don't always have to have a system that has 2 equations in standard form. These are both in slope-intercept form. So we can clearly see on both of these equations what our y-intercepts are, and we can clearly see what our slopes are. One thing I do want to point out, though, is this before we graph them, they have the same slope. Well, you know about lines that have the same slope? Well, they're either parallel, or they're right on top of each other if they're the same equation. And of course, these are not the same equation. Obviously, they have different y-intercepts. So let's kind of foreshadow a little bit here. This system has 2 lines that are going to be parallel, and when we look for solutions to a system, we're looking for any points that both graphs have in common or where they collide. And if they're parallel, they're not going to collide. So one thing I would like to already say about this system is I don't think it's going to have a solution. I don't think there's ever going to be a point that both graphs have in common at the same time. So we're actually going to graph this one in GeoGebra. It'll be a little bit easier, but we say the y-intercept on our first equation is negative 5. That's our b. We say our m on our second equation is 1/2, or up 1 over 2. So let's head over to our graphing utility here. We say we know that there's a point at negative 5 on our y-axis, and then it goes up 1, right 2, There's our line. So our second equation says our y-intercept is 3, and we have a slope of a half. Okay, so our y-intercept is 3, so we'll go up 3 on our y-axis, draw a dot. Then we'll go up 1 over 2, draw on our line, and we can clearly see that neither of these graphs, or none of these two graphs in this system, these two equations, will never have a common point or a point where they intersect. So at this point we'd say, well, parallel lines, that's one of our three cases there. We'd say this has then no solutions. It just doesn't. Okay. So now let's take a look at system number 3. Now I'm being kind of a jerk on this one. You'll notice that our second equation here is also in slope-intercept, kind of like on our last example. But this one up here is like very near to being in slope-intercept form. It's just that y is not by itself yet. So here's what we're going to do. We're going to put this in slope-intercept form. It's not unfair for a math teacher to ask you to do this. So we say, well, if I wanted to get y by itself, we could divide everything by -4. -4, I would divide everything over here by -4. So this would imply that our first equation, an equivalent form of it, would be y equals, now we have 24x divided by -4. That comes out to be 24 divided by 4, okay, is 6, so -6x. We'd say positive 4 divided by a -4 is -1. So the very first thing I want you to notice is this. Look at this. This equation is the same as this equation right here. So when we graph these, what does that mean? It means they're going to graph the same line. In other words, both of these equations are going to be right on top of each other when we graph them. What does that mean? It means that they share every single point throughout eternity. So this is going to be a solution, or a system, excuse me, that has infinitely, I'll try to write slower. I write better when I write slower. Infinitely many solutions. Why? Because when I graph them both, they have every single point in common. So let's go over here. We say, well, we've got a y-intercept of -1 and a slope of -6. So when we graph this, we'd say, okay, so get our line tool. We say down 1 on our y-axis. And we'll go down 1, 2, 3, 4, 5, 6 over 1. And when we graph the second equation, we'd say starts at -1. It goes down 6, right 1. But you can see clearly that these are the same equation. If I look up over here, we can put it in slope-intercept form, both of these. We say they are the same equation. So therefore, how many solutions do they have in common? They have all of their solutions in common. Okay. So now system number 4. Again, here I am. All my examples previously have been in standard form. I'm going to do these two equations in slope-intercept form. So what are some things I want to notice right off the bat? Well, the first thing I want to notice is this. Our m values, or our slope values, are not the same. So what do you know about two lines that don't have the same slope? Can they be parallel? No, they aren't parallel. And if two lines are not parallel, that means that eventually they have to collide. And if they collide one and only one time. That means that we're going to get a one solution case. I'm just foreshadowing here. How would I be certain that I'm going to get one solution? Well, the moment I know that they don't have the same slopes, I'm certain that they're not going to get infinitely many solutions or no solutions. They have to have one solution where they cross. But let's go ahead and graph both of these. So we say our first line has a y-intercept, or a b value of 3, and a slope of 3/4. So let's go ahead and graph that. We go up 3 on our y-axis. Let me get these guys out of the way. Up 3 on our y-axis. 1, 2, 3. And then we would go up 3, 1, 2, 3, over 4. 1, 2, 3, 4. So there's our line. Okay, slope-intercept form. And our second equation here says we've got a b value of -6 and then a slope of 3. So b value of -6 means it's going to hit down here at -6 on our y-axis. And we had a slope of 3. So 1, 2, 3 over 1. I think it was 3. Yes, it was 3. So the question is, what's the common solution here? And you can see that both of these graphs, they collide at this point B right here. And so that point B was over 4 up 6. So now part of our instructions here were not only to determine how many solutions this system has, which was 1, but if we had one solution, we would want to check to see the solution works. If we say 4, 6, we have to plug this back into both equations, because remember, a solution to a system has to satisfy everybody in the system to make sure it works. So in this case, we get y equals 3/4 x plus 3. So in this case, we're plugging in 6 for y, 6 4 for x, and we get 6 equals, now this 4 and this 4 cancel out, we're left with 3. We have 3 plus 3, 6 equals 6. So we know that at this point 4, 6 satisfies the first equation. Now the second equation here, we say y equals 3 times x minus 6. Again, we're going to plug in 4 for x, which is right here, and 6 for y, which would go out here this time, y, x. So we get 6 equals 12 minus 6. 6 equals 6. So this is a solution not only to the first equation, not only to the second equation, but 4 comma 6 is a solution to the system, okay, because it satisfies everybody in the system.